So this video is an introduction to the distributive property. Now in class tomorrow we're going to talk more about what the distributive property is, get some manipulatives going so you can really see how the distributive property operates. But what this video is going to do is going to give you the definition of it, a few different examples, some different ways of thinking about why it works the way it does work, and then we'll have some practice problems, of course, at the end for you to work on. And so one way we can think about the distributive property is by thinking about pools. And one of the things that we need or that we always ask about and think about at a swimming pool is how large is it, and therefore, because of how large it is, how many people can we fit into it? Now, if it's a basic rectangular pool, finding the area of the surface of the water is not too bad. But if you have a pool that's a little bit differently shaped, such as the L here, then there are a few different ways of going about it. And essentially what the distributive property does is it says, okay, well, the total area of the pool is the sum of its parts. And instead of using area and surface area and things like that, we use multiplication and addition and subtraction and the operations to form that kind of breaking down of problems. We can find the total area of the pool by adding together the pieces. The distributive property is about finding out what happens when you have a number of pieces added and subtracted, and you multiply or divide the whole thing as you move on. So we use the distributive property, like we said, to break a large sum or difference into its smaller parts. And let's take a look at exactly what that would mean with some food. So we're going to look at Reese's Peanut Butter Cups and apples. So the idea is, if we have this entire thing, if we had a collection of one Reese's Peanut Butter Cup and an apple, and we wanted to make several copies of that. Let's say we had lots of friends coming over, and you wanted each person who was going to be there to have a peanut butter cup and 2 apples. Well, if we're creating 3 plates that all have a peanut butter cup and 3 apples on them, then each of those plates is going to have a peanut butter cup, and it's also going to have 2 apples. So creating multiple copies of this group with peanut butter cups and apples means we have to create multiple copies of the peanut butter cup, and we need to create multiple copies of the apple. If we do the same thing with 2 peanut butter cups and 3 apples instead, if we wanted to make, say, 4 copies of it, then creating copies of that group of food means that we have copies of the peanut butter cup and copies of the apples. So it's not that just one gets copied, it's that everything gets copied when you're creating multiple copies of a group of things, especially in the example of food, if everybody needs to have the same thing. That, in essence, is what the distributive property does. The distributive property says that if you have a number that's multiplied by a sum or a difference, in this case, the variable a multiplied by b plus c, then you multiply a by each of the numbers inside the parentheses that are separated by addition and subtraction. The same thing is true. If we have b minus c, a gets multiplied by b and gets multiplied by c because we're creating a number of different copies of everything in the parentheses. So go ahead and write this down. You're going to write down, obviously, the title here. And then you're going to write down these 2 examples. If you want to draw the arrows that show A being multiplied by B and C, you are welcome to do that. But at the very least, you need to have both of these statements here. Write that down, pause the video, and come back when you're ready to move on. So let's take a look at what that actually means in practice. We're going to start out with an idea of just a simple product and sum. 5 times the product, or times the sum of 2 and 3. Now, on the one hand, the order of operations tells us that we can do 2 plus 3 is 5, and 5 times 5 is 25. And so we're going to use this here as our check to make sure that what we're doing with the distributive property makes sense. It wouldn't be a very good rule in math if we didn't end up at the same value that we did using the order of operations. So what this is saying is that this sum, 2 plus 3, is copied 5 times. So we can think about it as 5 times 2 and 5 times 3. And I'm going to draw this over here. So 5 times 2 plus 5 times 3. That's what the distributive property says. 5 times 2 is 10. 5 times 3 is 15. And we end up with the sum of 25, which is good because that means that the calculations we did were correct. Now we can also look at this and think about it like the multiplication of 5 times the parentheses. Multiplication is repeated addition. So we add this value here, 2 plus 3, to itself 5 times. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 copies of 2 plus 3. If we add the columns up, that is 5 copies of 2. The second one is 5 copies of 3. And now we're back at 25. Now for situations where we just have numbers and no variables, we can always just go through and do the calculations that are in the parentheses first and then eventually multiply them by the number, or at least simplify it as much as we can. We're not always going to be able to simplify entirely down. But where the distributive property really comes in handy is for things you can't simplify, like x plus 4. So in this case, this is x plus 4 added to itself 2 times. So we can think about it as x plus 4 and x plus 4. That's 2 x's and 2 4's. So the distributive property tells us to multiply 2 times x, which is 2x, and 2 times 4, which is 8, and then we keep the operation in the middle. The addition just drops down, and we end up with 2x plus 8. Let's take a look at another example here. So now we have negative 2 times x plus 5. Now this same idea holds. We're going to take the number on the outside and multiply it by everything that's inside the parentheses. But here, it's a negative 2, not just a regular 2, so the whole negative piece needs to come with the 2. Negative 2 times x plus negative 2 times 5, because the negative is a part of the number that's multiplying those parentheses. Negative 2 times x is negative 2x, and negative 2 times 5 is negative 10. And so this is our answer when we look at distributive property problems with variables. We're not going to be able to condense it all the way down to a single value. You cannot add negative 2x to negative 10 and create negative 12x. It doesn't work that way because the x is a variable and it changes. The value of negative 2x depends on the value of the variable, whereas negative 10, just is what it is. That value never changes. So this is it. This is as simple as we can get. Our answer is negative 2x plus negative 10. And if you're looking at this and thinking that it's a little bit strange to be working with numbers and variables and not come up with a single particular value, it is very different from the things that we have done before. And so if you're feeling a little bit uneasy, like you really want to continue and start combining more things, I totally get it. But this is where we have to stop, because there is nothing else that we can do at all to this expression until we find a value for x. So I've got a few pages of practice problems here. Go ahead and pause the video and work on these two. Remember, the number outside of the parentheses gets multiplied by everything inside the parentheses, and the operation in between stays the way it is. So go ahead, pause the video, work on these problems, and come back when you're ready to see the answers. So again, the number on the outside multiplied by everything on the inside, that's 3 times x and 3 times 7. So 3x and 21, because that's 3 times 7. And the subtraction sign just drops into place between them like it was before. So 3x minus 21. For the problem on the right, we have a negative 4 that's being multiplied by g plus 9. So negative 4 times g is negative 4g. The addition sign drops. Negative 4 times 9 is negative 36. So it's negative 4g plus negative 36, also able to be written as negative 4g minus 36. Either way is correct because adding a negative is the same motion on the number line as subtracting a positive. 2 more example problems for you to work on. Go ahead and pause the video and come back when you are ready to move on. So on the left, we have 5 being multiplied by x, 5 being multiplied by y, and the addition sign just drops in between. So we have 5x plus 5y. And then finally, on the one to the right, we have negative 8 that's being multiplied here. So negative 8 times x is negative 8x. Negative 8 times 4 is negative 32, and then the subtraction sign drops down. So if you ended the problem here, and that's what you got, that's fantastic. One additional thing we're always going to do with a distributive property problem is if we end up in this circumstance where we have minus a negative, negative 8x minus negative 32, we know that on a number line, subtracting a negative is the same as moving to the right on the number line, which is the same as adding a positive. So we are going to change this problem. Instead of minus negative 32, we're going to make it plus 32 because that represents more cleanly what motion we're looking at in a number line.